question 7. So for for the first bit, just remember that we have the two tensions forces going in this direction. So that's the only key bit, I think, from the narrative. So for part A, looking at the system as a whole, following Newton's second, F equals ma. So our net force is 4 less the 1 and less the 2, equaling the mass, the total mass. We're looking at for the systems, the 0.3, add the 0.5 times the acceleration. This allows us to work out the acceleration as 1.25. Now for part B, we're just using SUVAT. We know the initial speed is 0. We've just worked out the acceleration to be 1.25. The time taken is 6 seconds. So using v equals u plus at, we can work out v to be 7.5. Now for part C, to work out the tension in the rod, we could either do it for P or for Q. I'm going to do it for P. So our again, using Newton's second, our net force is T less 1, equaling the mass times the acceleration. The mass is 0.3, and we know the acceleration to be 1.25. For this one, I've considered a positive to be left to right. Now for part D, we're trying to work out the distance moved by P as the system decelerates. So the key thing to take on board here, once the force is gone, really the tension goes, and we're now left with thrust going in the opposite direction. So these two here I'm calling T dash, but note the arrows have changed in direction. So looking at the system as a whole for D, F equals ma, again Newton's second. So again, I'm considering left to right to be positive, so our net force is -1 together with -2, which is -3, a combined mass of 0.8, so our acceleration is -3.75. This then allows us to use the SUVAT equation, v squared equals u squared plus 2as. We've just worked out the acceleration to be -3.75, initial speed of 7.5, because that was the final speed of everything up here, and a final speed v of 0, so that allows us to work out the distance to be 7.5 meters. Now for part E, I'm just going to consider P. So our net force is the net is the thrust, the T dash, and the 1. I'm now considering right to left to be positive, so that's 1 plus T dash, equaling the mass of P, which is 0.3, times the deceleration, well, I'm going right to left, so I'm now using positive of 3.75. So that's gives us the thrust being 0.125 newtons.